In this video we're going to be looking at primitive data types. So when you're writing a computer program, we feed data into the computer and something happens inside the black box that turns the data we fed into the system into some kind of result which we call output. Now identifiers are used to, identifiers are used to locate where the data is. So your computer program, for the data that's fed into it, we need to store that in memory, and we need to know where it is so that we can go and find that data. And to do this, we give the piece of data a name called an identifier. Now data can be in one of two formats. We can have data which the programs cannot change, and this is called a constant. Or we can have a variable, which is a piece of data that the computer program can change. Now when you want to have a constant or a variable, we need to tell the computer first of all what type of data we're working with, and that way it can go off to its memory, its RAM, and it can find the amount of space that it needs to store that piece of data, and we do that by declaring a variable. So at the start of all your computer programs you should be declaring your variables, and this is your way of telling the computer how much storage to reserve to hold this piece of data. So to do this, you're going to have to give it a name, first of all the identifier, and then tell it the data type, and then it knows how much like how long it is, and it can go off and allocate go off to RAM, find some space and allocate that memory to your computer program. Now when it comes to data, we have different types, and these are defined in your computer programming language, so they are different for each type of computer programming language. And I should caution you that some languages use data in very different ways to others, but the basic idea is that a variable is a unique, as it says here, unique identifier given to a memory location used to store a piece of data whose value can change while the program is running, and that is a definition that you definitely want to commit to memory. When it comes to defining or declaring variables in Visual Basic.NET, the keyword you use at the start of the expression is dim, this dim keyword, DIM. You then have to give it a variable name which is unique. We then have the keyword as, which is simply says I want this variable to have this data type, and the data type needs to be one of the recognized ones that we use in Visual Studio and Visual Basic.NET. So some examples: dim counter as integer. This defines a variable that can hold a whole number. Total package as single, or total price as single should I say. This defines a variable that can store a real number. Name as string. This is declaring a variable that can hold a piece of text. And then register voter as boolean. A boolean is a variable that can have a value of true or false. So if you want to have these can be really useful. For example, if you're searching, you might declare a variable called found, set it to either true or false to indicate whether you found the item you want. Now if we want to do this, declare variables in C# programming language, the first thing we need to do is we declare the data type, and this needs to be one of the data types that the language recognizes. We then have a variable name which needs to be unique in that block of code, and then at the end we have an equal sign here, and then we have a value which is the value the variable is going to be set to initially. That's called initialization, and it's something you should always do. We then always end statements in C# with a semicolon. Now please note that you don't have to specify a value, because you can say simply type variable name semicolon, and that will create the variable, but it won't give it a starting value. Now examples here for C language: string name as equals Walter Mitty, so that will set you up a string that can hold piece of text, and the initial piece of text is Walter Mitty. Int counter equals 2, so that's defining an integer variable called counter, initializing it with a value of 2. Greeting equals hello, that's going to create a standard message with that piece of text in it. Double total price equals 5.99D. That's going to create a double precision variable. We'll come on to what those are later in this little video. Magic letter is D, so it's defining a single character. Notice the keyword is char, and then finally we've got bool, which defines a boolean variable called found and sets it to have an initial value of false. Now constants are things that can be incredibly useful in programs. They can make programs far, far, far easier to read and to understand. So a constant is simply an identifier that refers to a memory location that's got a piece of data into it, and the key thing here is the data cannot be changed while the program is running. It's not possible to change the value of a constant. What you never ever want to say is a constant is like a variable, because variables can change. They don't have to, but they can. Constants cannot be changed under any circumstances, so they're quite different in terms of what they can do and how we use them in programs. Now, to declare a constant, you declare them in a very similar way to the way you would declare them in a variable if you're using the Visual Basic language. So the only big difference is that we use the keyword const instead of the keyword dim. So dim means is short for dimension, and it creates a space to define, tells the way that I like to think about it is it defines the dimensions of the variable, whereas const simply says this is a constant, and the key difference here is that we must specify a unique keyword. We need to specify data type just as with a variable, and then at the end we specify the value the constant's being assigned, and remember this value cannot be changed. Now in the C language, again we use the keyword const. We then give it a unique identifier, so a name. We give it a recognized data type, and at the end we say equals value, and again the equals value part is not optional. We have to specify it for constants, and statements in C# end with semicolons. Now here's some examples in C#. This is declaring a string constant called p-word, which is Walter space Mitty, so you could maybe use that to hold a password in a program, although to be honest, hard coding passwords into programs is a terrible idea, so please don't ever do it. This here is declaring an integer variable called days in week and assigning it the value 7. This here is declaring a double precision floating point number called pi, which has a value of 3.14. A piece of text with the word hello in it, and so on. So all of these are both constants and variables are called primitive data types, and they're called primitive data types because they can only hold a single piece of data or a single value. We also have data structures that can hold collections of values, but we'll come on to that in a later topic. So we have two types. We have numeric and we have non-numeric primitive data types. For numerics, we have integers which hold whole numbers and real numbers which have a fractional part, and these are probably referred to as floating point numbers. And then for the non-numerics, we have strings which can hold either characters or digits, and this is a digit as in a symbol for a digit rather than a number. We have characters which again can hold a single character, so a string is simply a group of characters one after another. And then we also have booleans which hold a value of either true or false. Now for the numerics in Visual Basic and Visual C#, we can specify integers, and note that these can store either positive or negative integer values, and these 4 bytes of storage, and that 4 bytes is significant because that limits the maximum value that an integer can store. So for that reason we also have a type of integer called a long integer, which is called a long, and that uses, as you can see, 8 bytes of storage rather than 4 bytes. Now do remember that although we're doubling the amount of storage, that significantly increases the range of the value. If you want to find out the ranges, these are documented in the Microsoft documentation, which you can find by just simply Google VB.NET data types, and you can find out the exact maximum and minimum values that can be stored in these data types. For real numbers, we have a similar kind of idea. You have a data type called single, which holds positive and negative real numbers using 4 bytes. We also have a data type called double, and this uses double the amount of storage, but significantly not only can it store larger and smaller values than a single can, it also stores them with twice the precision, because when you have very, very, very large real numbers, we use a format called floating point. And single and double actually are short for single precision floating point, double precision floating point. This is a little bit like standard forms in maths, but what happens is we move the position of the binary point, which is the equivalent of the decimal point in binary, and we move that to the left or the right. Now the problem when you do that is you lose some of the least significant digits, and therefore we lose accuracy. So when you're using double values, you get much better results if you're doing maths with very large and very small real numbers. Finally, the last variable data type last data type that you can use for variables or constants that we're going to refer to is currency, and this is used to store fractional values for money, and that store uses 8 bytes, and that significantly will allow you to store a currency type such as the pound or the euro or the dollar. Now for non-numeric data types we have strings. A string can hold pretty much anything, so it can hold letters, it can hold numbers, it can hold punctuations, it can also hold numbers in character format. So if you think of the digits 1, 2, 3, that could either be the number of 123, or it simply could be the symbols 1, 2 and 3. So if you want to store the former, you do that. Quite often we will use string to store telephone numbers, because telephone numbers have a habit of having things like +44 appended to the start of them, or prepended to the start of them, and also people sometimes put brackets and spaces in them. Dates, we have a data type called date that uses 8 bytes. That holds dates in the format, the UK format, day, month, and then 4-digit year. Boolean, and that holds the value true or false, and it uses a whole byte of memory to store a Boolean value. Now notice that VisualBasic.net does not actually support a data type called character. So if you want to store a single character, you actually have to define a string, but that's no big deal because it will just use 1 byte to store the character that you specify. Now here's some examples in VisualBasic.net. The key thing here is the variable names must begin with a letter and cannot contain any spaces or symbols. So dim score 1 is integer, dim date of birth is date, dim student name is string, dim found as Boolean, and so on. In C#, similar kind of system. Again, no spaces allowed in the variable or variable names. Int score 1 equals 0. String student name is Ken Dodd, or double pi equals 3.14. And dim found as false. Notice how each of these ends with a semicolon, which tells the C# compiler where the statements end. And there you go. That's data types in primitive data types, and how to declare them in both VisualBasic.net. Finally, we'll just wrap up by talking about camel case, which is a convention used for variable and constant names in a lot of languages. The idea here is that you should always give variable and constant names meaningful identifiers. In other words, phrases or words that express exactly what the piece of data contains. So for example, date of birth. Now to do that, what you simply do is you take the words, you put them together, you then start off in lowercase, and then every time you get to a new word use a capital letter, as in camel case up here. Another convention that you'll often see programs using is whenever they define a constant, they define it in uppercase, and that makes it immediately apparent to the reader that whenever they see uppercase, they're referring to a constant. Whenever you see camel case, you're referring to a variable name, and so on. Anyway, that's primitive data types in VisualBasic.net and C#.